Hello friends, welcome to our channel Mechanical Motivator. In this video, we will be seeing a problem on balancing of several masses rotating in the same plane. So this is the third case. Here what we're going to say is we're going to balance several masses and all the masses will be rotating in the same plane. So in this problem, we'll be seeing both analytical as well as graphical. First, we'll solve the problem by analytical method and then we'll be solving the problem by graphical method. So what is the question is we are having four masses M1, M2, M3, M4. So respective values they have given us. So M1 200 kg, M2 300 kg, M3 240 and M4 260 kg respectively. The corresponding radius of rotation values also they are given. So R1, R2, R3, R4 values they have given, and the angle between successive masses. So theta 1, so initially we will be having 0 degree, right? So initially the origin or the starting point will be 0. So theta 1 will be 0 degree and theta 2 is 45 degree. So successive mass means, so from mass 1, M1 and M2, the angle is 45 degree. And from mass 2 to mass 3 is this angle is 75 and mass 3 to mass 4 is 135. So this is the reference. So first mass is 200 kg. So this is the reference. So first value will be 0. Theta 1 will be 0. So it's a horizontal line. And theta 2 is a 45 degree. So second mass 300 kg. It's a distance of 45 degree from mass 1. And third mass is 240 kg. The third mass is at a distance of 45. Previously we are having 45, right? 45 plus 75. Because successive masses they have given. So 45 plus 75. So total 120 degree. So third mass 240 kg is at an angle of 120 degree from mass 1. So mass 1 is the reference. And fourth mass. So fourth mass will be at a distance of 45, 120 plus 135. So 45, 70, 75 we got here, right? 45, 75 and 135. So totally we will be having 255 degree. So total the fourth mass is 260 kg. The fourth mass is at a distance from reference mass M1 is 255 degree. So now we have drawn the angular position of the masses. So these are the angular position of masses. We going to determine the mass. This is the unknown mass, or we going to this is the mass which we need to determine value, and we also need to determine how much angle it's from reference axis. So reference mass, that is M1, how much angle it will be from mass M1. So M will be the balancing mass and theta is the angle which the balancing mass makes with the reference one. So M1 R1. So we will be having we need to form the tabular column, right? So here we need to form the tabular column for centrifugal force. For that, what we're going to do is we just multiply mass and radius. So M1 into R1, just write the value. Same by write for 4 for M1 R1, M2 R2, M3 R3, M4 R4. You just multiply and write the values. So mass is in kg and radius is in meter. So unit is kg meter, and these are the centrifugal force. So here we form the tabular column. First one will be serial number and second one is mass. Write the 4 masses and write the 4 respective radius. Just multiply these two tabular column and you will be getting the centrifugal force. So in this tabular column we can divide it by omega square, as I already clearly explained in the introduction video. So if you have any doubt, just see the introduction video and then come to this problem. So unit is kg meter. So here we are having the 4 different values and this is the force polygon. So using these 4 values, we can plot the force polygon in graphical method. So now first of all, we will be doing analytical method, right? So resolving, that is if we resolve the masses in horizontal and vertical means horizontal, that is summation of horizontal forces will be M1 R1. So horizontal means we'll be having cos theta, vertical means we'll be having sin theta. So this is the formula. We know all the values, theta 1, theta 2, theta 3, theta 4, all values we know. If you substitute means you will be getting 21.6 kg meter. If we resolve vertically means substitute all the values and you will be getting 8.5 kg meter. So resultant, that is R is equal to root of summation of horizontal forces square plus summation of vertical forces square. So finally you will be getting a resultant value as 23.2 kg meter. So this is the resultant value. So now we know that MR is equal to resultant. So M we need to determine radius. Radius we know. So it is revolving at a radius of 0.2. It's given in question. So see here, find the position and magnitude of balancing mass. We need to determine the magnitude, means kg, and how much on what angle it's revolving. So they have clearly given that the balancing mass is rotating at a radius of 0.2 meters. So r is equal to 0.2 meter. So just substitute the r value. Yeah, just substitute the r value, and resultant value, so we can easily calculate the mass. So mass is 116 kg. So this is another formula which we already saw in introduction video. So tan theta dash is equal to summation of v divided by summation of h. These two values we know. Just take tan inverse to the other side. So tan inverse. So finally we'll be having an angle of 21.48 degree. Actually this is the angle. So listen here. Actually we need to calculate from 200 kg. So if you calculate, means here it will be having 180. So 180 plus 21.48. So that's what they have written here. Since theta dash is the angle of the resultant r from the horizontal mass 200 kg, therefore the angle of balancing mass from the horizontal mass, that is 200 kg, is 180 plus 21.48. So finally we'll be getting an angle as 201.48. So we can easily plot the theta value is 201. So 201 degree we can plot the mass, and value of the mass is 116 kg. Analytically we have found. Now we are just going to cross check with graphical representation. So graphically how we going to draw? We know all the values. As we saw, just multiply the mass and radius and have the values as we have before, and we can easily draw the angular position. So draw the angular position of mass m1, m2, m3 and m4. Don't draw this m. So we need to determine, right? After solving, we will be plotting here. So resultant we will be having here. So opposite will be having the mass. That's what. So here we will be having the resultant. Opposite will be having the value of the masses. So first of all, what we're going to do is we need to set the values, as we already got in the tabular column. So tabular column we are having values, right? So first one is mass for 200 kg. It's 40. So first of all, we need to set a scale, that is 1 centimeter is equal to 10 kg meter. So divide all the values by 10. So here we will be having 4, 4.5, 6 and 7.8. So first draw 4 centimeter, that is 40 means, if you scale means 4 centimeter. So A to B distance is 4, the angle is 0 degree. So this is 200 kg. So first mass is 40 kg meter. So if you scale means 4 centimeters. So for 4 centimeter, draw a horizontal line. Next mass is 300 kg. So the angle is 45 degree. So for 45 degree, you know the value of the mass, that is 45 kg meter means 4.5 centimeter. So length is 4.5 centimeter, angle is 45 degree. So from here, just put a cross. From here, take 45 degree, like this 45 degree, and draw a line. The length of the line is 4.5 centimeter. The third mass is 240 kg. So 240 kg means the angle they have given clearly. So total it's 120, right? 120 degree. So from C, take 120 degree and draw this line. So this line and this line should be parallel. So just keep in your mind, just put a cross and take 120 degree and draw the line, and length of the line is 60 means 6 centimeter. So C to D distance is 6 centimeter and angle is 120 degree. So finally you'll be getting the point D. From there we know the angle for the fourth mass, that is 255 degree. From here draw a line for 255 degree. Try to keep your protractor upside down and just measure and just subtract from 180, so that you will be getting this angle. So the thing is, you have to draw this line for 255 degree. That's it. So 255 degree, draw the line, and the length of the line is 78 means 7.8 centimeter. So length of the line is 7.8 centimeter and angle is 255 degree. So finally you'll be getting a point E. We know very well that in a polygon, the closing one will be giving the resultant value. So just close the polygon with a dotted line, and this dotted line will be giving the resultant, that is AE. So AE value will be getting us 2.4 centimeter. If you measure and see means, you will be getting 2.4 centimeter. And here we did scaling, right? We divided by 10 means finally we need to multiply by 10. So just multiply by 10 since we use the scaling. So finally you'll be getting AE is equal to 24 kg meter. So AE is nothing but M into R. So m into r is equal to resultant, right? We saw here itself. M into r is equal to resultant value for us is 24. So r value we know 0.2. So 24 divided by 0.2 means we'll be getting the mass as 120 kg. So now we are determining mass. Now try to measure this angle. That is resultant. We got a dotted line, right? If you try to measure means you'll be getting 201 degree. You have to measure in anti-clockwise direction. So if you put a cross means here we will be having 180 degree, and remaining angle if you add means you will be easily getting remaining, you will be getting like 21 degree, I think so. If you keep your protractor upside down, here horizontally you will be having 180 degree, that is one semicircle. Here 180 and remaining angle will be 21. So 180 plus 21 will be 201 degree. So finally you will be getting 201 degree, and we need to measure from that is the we need to keep this as a reference and measure. If you measure means you will be getting 201 degree, and after measuring it you plot the mass which we got 120 kg, right, for the angle of 201 degree. I hope so it's very clear for you. In case if you have any doubt means you type in the comment section. Please do subscribe to my channel and press the bell icon. So, and also share the videos with your friends. If they get benefited means it's well and good. Thanks for watching this video. Have a great day.